Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 1818 called minimum absolute sum difference. So pretty low acceptance rate. It took me quite a few tries, but again, I'm super happy that I was able to completely solve it on my own without any help at the end. So let's do it again. So this is 1818 minimum absolute sum difference, like I said. So you have two integer arrays, and basically you want to minimize when you add the absolute differences of this minus this together. And you want to do that by replacing any one element with any other element. So let's go ahead and create a sorted set of nums1. That's going to help us because we want to do the replacing in this nums1 array. And then let's just go ahead and first get, so the answer we're trying to minimize. So anything is going to be less than or equal to infinity, right? So let's just first get the base cost, which is just going to be the first answer we see. So for I in range length nums1, so the difference is absolute difference of nums1I minus nums2I, so absolute 1 minus 2 plus absolute 7 minus 3 plus absolute 5 minus 5. So that's going to be the original. Let's call this original. And then we're going to add that difference. And then we're going to minimize answer with the original, right? And at the end, we want to return the answer since this is not going to be the answer because it's obviously the first one we see, and we're trying to minimize that. So how do we minimize that? Well, let's get another sorted list, and let's actually just make this a list. And let's append, first of all, the difference. So we're trying to make this as close to 0 as possible, right? Because this is always going to be a positive number. This is an absolute difference. So 1 minus 2 is going to be from -1's absolute value is 1. So this is what we're interested in, what we're sorting by, and then this is what we need to change. And then this is the target, and then this is just used to keep the index location that we're trying to find so we can locate the target in nums2 later on. And yeah, so let's do exactly that. And let's also sort this by the difference because the difference is what we're trying to minimize, right? Okay, so if we print SL, you can see that. So this is what we're sorting by, and everything else is just the original order that it was in. So cool. So now let's go over each element in our array, right? And again, we're trying to minimize this. So first of all, if a is already equal to 0, then we don't need to do anything, right? Otherwise, then we can go ahead and try to find. So the original difference is this. This is what we're trying to make closer to 0, right? And so why don't we just go ahead and find, so the target is C, and the index is 1. So now what we want to do is find a value that somehow makes it different. So first of all, let's go ahead and, this is why this is useful, let's discard B. So this is the original value, and then because we can't pick the same value more than once, any other element, right? So now what we're going to do is run a binary search on, after we discarded, this is still in sorted order, right? And we're going to do it on the target, which is going to be C. That's what we're trying to make closest to, right? So you can see here that this is still in sorted order. That's the power of the discard method here. And then what we're going to want to do is, first of all, if this binary search, which finds the closest value in this, closest value to C inside of SS, right, which is just the original sorted set of this. So unique and then sorted from smallest to greatest. And then here, if this is in bounds, then we know we have a valid answer. So the new value is SS of BL, right? Okay, so let's print the new value, which is going to result in a new difference because the original value is just going to be A or B, right? So that's the original one we're trying to replace. So if any of these to the target results in a closer sum, so in compared to this, if this is closer to this in absolute difference than this is to this, then we replace it, right? So then basically we want to just hold the original value. So let's go ahead and make a deep copy. So let's call this O is a deep copy of nums of 1 so that we can keep going back to this, reverting it every time we go through this loop. So basically now we can just say we basically want to replace this index, which is why we kept track of it. So for example here, we want to replace 7 with 5, right? So basically, instead of having to replace it and then recalculate all the differences of the sums again, let's think about something else, right? So let's go ahead and first do that. Let's say O of D is equal to new value, and then let's call this new diff for I in range length of O. New diff is plus equals to O of I minus basically the actual index itself, which is nums2 of I. So that's why this is also useful. So we can get the same corresponding position in nums of 2 as well. And then again, we want to minimize answer with this new diff in case it is smaller. And so again, because we discarded this, we have to put it back, right? We have to add that back because let's see what's going on here. So let's actually get rid of this. Maybe that's causing some problems. So, okay. So it's not, because again, you can't get smaller absolute difference than 0. So that was my thought process there. And then, okay, let's go ahead and submit this just to see how many tests we pass. And then again, at the end, obviously you need your modulo, so let's do that. Plus 7. Okay, and then modulo mod. So that's not really going to make a difference here, but let's go ahead and add that. Oh, and the other thing, we have to go ahead and re-add this to the original value, right? We have to resort it back to B. Okay, I don't know if there's a network error. Okay, so that was part of the problem there. And let's submit this again. Because again, we're trying to resort it to this every time we run this loop. Okay, so wrong answer, because the way bisect left works is it finds the leftmost value that's equal to C in this sorted list. Let's also try bisect right. So let's do the same thing. Is bigger than or equal to 0 and BL is less than length of SS. Then new value is SS of B right, and O of D is equal to new value. New diff is 0 for I in range length of O. New diff plus equals to absolute O of I minus nums2 of I. Answer min. Answer new diff. O of D is equal to the original. So, okay. So, bisect right finds the rightmost value, and, just play around with this a little bit. Maybe it's -1. Okay, and in this case, it happens to be, so let's submit it. And bisect right, I think it might actually find the first greater value, so maybe this is the last one, and then this is the leftmost value equal to C inside of this, and then this is the rightmost value inside of this, so we get time limit exceeded. Good, so we're at least on the right path. This makes it n squared, so why don't we do something here? Because instead of doing this, new diff, we already know the original base is just going to be total, right, from this. So let's call this total or the original base is just the original sum, right? So why don't we just say original minus whatever the previous difference was, original difference, which is at position A, and then we're wanting to add the new difference. And the new difference is just going to be the absolute difference of the new value instead minus the same thing, which is just C, right? So that is nums of 2 of I, which is C. So then that makes things a little better, and we can do that here as well. So the new value, new diff is absolute new value minus C, so we don't have to loop through. And then the new, new diff is going to be original minus A plus new diff. And then that saves a little time. Okay, let's submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.